Hello everyone, today we're going to be solving the second Leetcode problem. We will be doing it in JavaScript, and I'm going to solve it in real time, speaking my thoughts, sort of like this sort of interview question. Okay, so the prompt for the question, the title is add two numbers. The prompt is you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero, except the number 0 itself. Okay, so we have an example. Input 2, 4, 3, plus 5, 6, 4. Output is 7, 0, 8. Okay, this means we are returning a linked list as well. Oh, each node is a digit of the number in reverse. Why would they do that in reverse? Okay, so I'm going to sit here and think about the problem for a little bit. As well, if I don't like the solution I do, I will at the end code a new solution that I like better. Okay, so to start with, we're going to write a recursive function that allows us to turn a list node into an integer. That way we can turn both of these list nodes that are inputs into integers, sum them, and then return that answer. So let's get started on that function. We're going to call it toInteger, and it's going to take a list node. We're just going to call it list. And then in this function body, we need to get the val off the node and the next off the node. And then, let's see, take that val and turn it into a string, and then add that string to the result of calling toInteger again on the next value. So let's get the value off the list. We'll call it val equals list.val, and next equals list.next. And then, like I said, we're going to return the val as a string, plus we're going to call it toInteger again, passing in the next node. So this function takes a list or list node, and then takes a value off of it, takes the next list off of it, and then returns the string of the value plus toInteger of next. And we know that toInteger returns a string because that's what it does here, and the plus operator for strings just smashes them together. And because it's in reverse order, I believe, so the first time it gets called, using this example, we'll get number 2. We're going to add the number 4 to it. So I think we have it backwards. We might want to call toInteger first plus string. So return toInteger next. Yeah, I think this is correct. Plus string value. Okay, so that gives us a reverse ordering. And one other thing we need to fix is the base case of this recursion. Otherwise, it's just going to keep calling toInteger over and over, even though we're going to run out of our list. So if next is null, then we're done, and we can just return our current value as a string. So if not next, or rather, if next is null, then return string value. Oops. And we could probably simplify this. Let me think if I actually do want to simplify it or not. Okay, so I've decided to leave simplification to the end, and we'll just move forward like this and try to get the right answer before making any changes. Okay, I don't know what's going on with my formatting here. Okay, that's better. So now we can call toInteger on a list and get back a number as a string. We still want to return, or we want to turn the number into an actual number value, rather than a string. So we have to keep that in mind. So our first number, they're calling it L1 and L2. I'll stick with that, call it N1, is toInteger of L1 as a number. And same thing here. I'm going to change this to N2, change this to L2, whoops. And now we should have both of the integers as number values. And all we should have to do now is return the summation of the two. So let's see if this works. Great, we got the wrong answer. We returned undefined. That's honestly a little bit unexpected. Let me think about that for a second. Okay, so I actually forgot something really important, which is that the expected return value is also a list node. So we do have the correct integer here, but we need to turn it into a list node. So for that, we're going to define a new function called toListNode. It's going to take an integer and it's going to return a list node that is also reversed, and that will be our answer. So we're going to define toListNode. Like we said, it's going to take an integer. We'll just call it number. And then what we need to do inside this function is take this number and turn it into a string, and then split that string into each individual character or digit, and then turn those digits into their integer values, and also reverse that list. And that will give us an array, which is close to what the list node we need, or it is similar to the list node that we need, but it's an array. And then we'll just take that array and turn it into a list node using a reduce function. So let's do that now. So like I said, we need we're going to turn our number into a string, but what we're going to end with is a list of digits. So string number, and then once we have a string, we can split it into individual characters. This is a trick in JavaScript to split a string into each individual character as an array. And then, and then once you have that, you want to reverse it, which we can do like that. And then we also want to map each individual character into a number. So we have a character here, and we want to turn it into a number. So this just barely fits on screen, but this should be our list of digits in reverse as integers. And then I don't know if I would actually oops. Oh no, what happened? It doesn't like that. So I'm going to wrap it. Maybe it'll like that a little bit better. I don't know if I would actually do this in my production code. I don't think it looks that pretty. Yeah, I don't like it at all, actually. But let's leave it alone for a second and then move on. So now we have our list of digits, and we want to turn them into a list node. So to do that, we're going to do a reduce of our digits, and inside the function that we're going to define, the first argument is our eventual answer, and that is going to be a list node. So we'll call it list, and then our second argument is each individual digit. So we'll call that D, and then define the function body, and then let's create some space. And the second argument is the value that we want to start with. We're going to set that to null because that is the end value of a list node. And that way we can treat each function call the same and just set our next list node to be the list node that was passed in to the function, or in other words, whatever is passed in right here. So to do that, we need to be able to turn a digit into a list node, and we are given a function up here that defines a list node. We're going to steal it and make it accessible. and get rid of these. And we also need to be able to define what .next is going to be. So we're going to take that as a parameter as well. And now we are able to create a list node by calling this function. So down here, inside of our function, or inside of our reduce function, we're going to return a list node that has the value of the current digit that we're on in this reduce, and then the next is going to be the last list that we were passed. So for the very first function call, that's going to be null, and then the second time reduce is called, it's going to get a different digit, and it's going to set next on the list node to be the result of the previous function call. So for example, if we looked at the output here, if we had 7, 0, and 8, or rather we have 8, 0, and 7, but we reverse them, and then we have 7, 0, 8, and the first time that the reduce function is called, it's going to be called with arguments null and 7. So we're going to create a list node where the current value is 7, and the next, or this dot next from line 16, is going to set the next. It's going to set the value of next to be null for the first one. And the next time reduce is called, we're going to be on 0, so D is going to be 0. And then we're going to create a new list node with val set to 0 and next set to a list node where the current value is 7 and the next value is null. And then we'll just keep doing that in the reduce until we get to the end. And then, so this should return us our list node correctly. Okay, so I forgot to do something really important here. Actually, I forgot to delete it in my testing. But right here, we did not have new before. This keyword is actually really important because the way they define list node is by setting this .val equals val and this .next equals next. And in order to use the keyword this like this, that's confusing, in this side of this function, it does have to have the new keyword. I don't necessarily love that, the way they defined it. I probably wouldn't do that myself. Maybe I'll change that and post another solution in this video after this. But for now, we'll just work with that and say, we'll just include this new here, and that does give us the right solution. Great, so that was accepted. We're going to try to submit now and see how this goes. Okay, we totally failed. Let's go see what the problem might be and get back to it. Okay, so I played around for a little bit and I realized a couple things about how they want us to solve this problem. And so one thing I want to cover is why our solution failed. And that is because with a number this large, when you convert it into a string, it goes into scientific notation. So I believe it was something like 1 plus e to the 30th or something. And so that's the e and the plus being converted into numbers, and which is not possible. So that was one problem. And the other problem is with a number this large, in JavaScript, it actually loses the ability to do addition. So you can't just add two numbers of this size together and get the correct result. JavaScript's funny like that. There's a number.max safe integer we can compare against and see if we're too big. We're not actually going to do that. There's another way to handle this, and that is instead of turning them into numbers, like on line 39 and 40, we could do a big int. There's something called big int in JavaScript. And I think this might just solve it for us, but I'm going to not go down that route. Even if this works, I'm going to show a different solution because I think I realized why they are giving us these numbers in reverse order. Maybe I should have thought about this more earlier. Yeah, it did work. That's totally fine. But I think we're actually going to rewrite this whole thing because I want to do addition manually, and it seems that's kind of the way that this problem is pushing us. So let's go ahead and kind of just start over and go down the manual addition route, which I think they meant for us to do in the first place, rather than doing this conversion from individual digits into strings, into numbers, and then back into list nodes again. Let's basically scrap everything. And I know that we did reach a solution. That's cool. And it is okay to scratch things once you realize that the problem that we're working with is not what we originally expected it to be. So starting over, I think we're going to try to do this in one big recursive function. So I'm actually going to define that out here. And basically what it's going to do is take two numbers, two list nodes, in reverse order, take off the last or the current node of each, sum it together manually, and then add that number to the result of calling itself again. Let me think about that. Okay, so I do think I know how I want to approach this. We can do it with the recursive route. You might watch me struggle a bit here because I can't imagine it perfectly well in my head, but let's give it a shot anyway. So we're going to call this add. It's going to take, I don't like calling things node 1 and node 2, but let's start with that for now. And in our function body, basically what we want to do is take the current value of both nodes, add them together, and then if there is a remainder, note that, but take the modulo 10 of that addition, make sure that we have the right number, and then if there is a remainder, we're going to call add again. It's actually going to take a remainder parameter, because if there is a remainder, then we need to add another one to the current value. So the way that we're going to do that, and this might get so tricky. Man, do remainders work like this? I haven't done manual addition in so long. Let's go. Anyway, so val1 is node1.val, val2 is node2.val, and then we're going to add these together. They're already numbers, so that's good news. So our, we'll call it answer digit, let's call it digit, is going to be val1 plus val2, and this is going to be anything up to 18. It'll be between 0 and 18, because 0 and 9 are the full range of values that val1 and val2 could be. So we'll say, let's call this sum, and then we'll say our digit actually is going to be sum modulo 10. So if it's less than 10, that's fine. It'll just be the number itself. So let's say sum is 9, then our digit's going to be 9. But if sum is 11, then our digit's going to be 1. And we'll say has remainder is digit modulo 10 is greater than 0. So for example, if we were adding 8 and 9, we would get 17. 17 modulo 10 is 7, which is greater than 0. Because 17 modulo 10 is 7. Oh dear. But 10 modulo 10 is also 0, so that's not right. I think we need to divide by 10. So 17 divided by 10 would give us a number at least 1. Okay. So digit, if it's 10 divided by 10 is 1. So if it's equal to 1 or greater, then we have a remainder. So 17, so anything, so 10 over 10 is 1, 11 over 10 is 1.1, etc., etc. But 9 divided by 10 is 0.9. So that should work for has remainder. And then to get our answer, we're going to return add of node1.next, node2.next, and has a remainder plus the digit that we just figured out during this iteration of the recursion. So there's definitely some things that we're missing here, and that is we don't actually want to work with digits, so we need to make sure this is a string. We don't want to work with numbers, sorry. So let's make sure this is a string. And the other thing is we don't have a base case. We also did not handle the remainder. So I wonder if remainder needs to be more than just a Boolean. We'll think about that in a second. So our base case is going to be that node1.next or node2.next is null. So that's interesting. Right now I'm assuming that our numbers are the same length, but that's not necessarily true either. So if node 1 was only 3 digits and node 2 is like 10 digits, how do we handle something like that? Oh boy, I have to think about this. Okay, so I thought about it, and it's actually not that complicated. Basically, if node 1 or node 2 is null, then we will just add 0 instead of adding a value. So in order to do that, we're going to set val1 to, we're going to check if node 1 is null or not. If it's not null, we'll return the value, otherwise return 0. Same thing here. Whoops. I'm just going to paste that line and change 1 to 2. And this gives us val1 and val2. And this will give us the ability to add 0 instead of adding an actual value in case the numbers are different lengths. We also need to handle a few other things. For example, when we call the add function and one of these is null, we are handling the value, but we also need to handle the next reference. So instead of being able to pass in node1.next and node2.next, we need to just keep passing in null instead of trying to get .next off of null, which is going to cause an error. So next one is same thing here, node1.next or null. Next two is node2.next or null. And here we'll say next one and next two. Whoops. And there's still something else that we're not handling here, which is the remainder. But let's think it through a little bit here. And I think we might have to do more than just doing remainder is true or false. But let me think. Maybe not. Because there's no way to have a remainder of 2 in arithmetic addition, right? I don't know. But anyway, the way to handle the remainder is we'll do val1 plus val2 plus an additional 1 if there was a remainder. So plus remainder, if there was a remainder, then I want to add 1, otherwise add 0. And this gets us to, I think, a nice place. So if we ran this through, for example, with like the values, let's say node 1 is 35, and node 2 is number 2. The first time this is called, node 1 is going to have value 5, node 2 is going to have value 2. So we'll get through here. Our sum is going to be 5 plus 2, which is 7. There's going to be no remainder, and the digit will be 7, and it will not have a remainder. And then we'll call add. Again, we will recurse, and node 1 will be 3, and node 2 will be null. And then if node 2 is null, then we'll handle next correctly, we'll handle val correctly. We'll add 3 plus 0 plus no remainder is 3. And then we'll recurse again by calling add with both of them being null. And when that happens, we're going to get the empty string. And so the final answer is empty string plus the digit 3 plus the digit 7, which is the answer of 37 plus 2. It would be good to maybe run this through with something that would cause a remainder. But I actually feel pretty confident, so maybe I'm just going to run this. Actually, sorry, we implemented the add function, but we haven't used it yet. So in our actual add two numbers function, which Leetcode expects from us, we simply need to return. Oh, no. This is not correct. We have our answer here, which is the addition of L1 and L2, and we could pass false here, but we set a default variable on line 19, so we don't have to do that. So here's our answer in, let's see, as a string, but we want it as a list node. So this is where it gets a little bit tricky, but basically instead of doing the recursion and then adding a digit to it, we're going to return the answer that we want directly from the function. So that means we need to take one more value, and that is our next node, which will start with being null. So in order to do that, our return function is going to look a little bit more like this, where add takes next one, next two, has remainder, and our next node is actually going to be, whoops, I messed something up here. Sorry, wait a second. I think we need to make a node. Correct. So let's make a node here of our current digit value, and that's going to be digit, and our next digit is going to be the result of the recursion. Okay, this makes a lot more sense. This should be list node. I messed up. So here, our current one's going to be digit, and the next one is going to be the result of adding that, the result of calling add with next one, next two, and has remainder. And then, wait a second. I don't need next node. I'm wrong. Sometimes I'm wrong. That's okay. Maybe we should think about this. But if we have a node here, so let's say our answer was 807, like in the example on the left. So the first number we would get was 7, and then we would put that as the first node, and then it would point to the result of calling add on next one, next two, and has remainder, which we assume is 0, and that one's going to point to 8, and then which is eventually going to point to null. How is that going to happen? Oh, okay. That just means our base case needs to be null instead of empty string. I think that makes a lot of sense. And instead of assigning it to value node here, we can just return this list node. So let's hope that this is correct. We will at least find out by submitting it. We don't need this anymore either. We can just return it, which is actually really funny. We could do this all in one function, but let's make sure this works first. Okay, so we have ourselves an error, missing initializer in const declaration. Oh, right. Equals function definition. I'm not sure how I got that one wrong. Okay, so we got undefined. That's super fun. Might have to think about that for a second. Oh, same problem as before. We need to put the new here. Okay, so we got 707 instead of 708. Okay, so it looks like our remainder isn't working. We have to remember that these are in reverse order, so the answer should be 807, but we're returning 707. And that is because I used digit here instead of, why does backspace not work sometimes? what we should be using here is not digit, but sum. So let's see if this works. Awesome, that's great to see. Let's see if we will get the summation correct. Okay, so we're getting 0. And we should be getting 10. Okay, so it got us on our manual math because what's happening here for this example, we are we're calling add the first time with 5 and 5. And then the next time it is null and null, which triggers our catch case here. However, it has a remainder. So what we're not handling is the length of the number getting longer. And that is a little bit more challenging to handle. I might have to think about this for just a second. Okay, actually this is not as complicated as I might have originally thought it was. We just need to check if there is a remainder and return a list node if there is. So we'll just do a ternary here. So if remainder is true, then we will say new list node. We're not going to forget new this time, of 1 and null, otherwise null. And now, when we get to this case, if there is a remainder, we're just going to add 1 to the end of our list, which is exactly what we expect. Hey, and we finally got it right. So that is 2 solutions, 2 different ways. I actually want to clean up this code a little bit, so stick around for just a second while I show you that we can do this all in a single function. And because this is a argument that has a default value, we don't need to worry about how it's called. And we can just move all of this. I copied too much. We can move all, this is still not working. Move all of this into here. Get rid of our add function. And now we have a nice single function definition that does everything we need it to do. We could possibly make this a little nicer as well. We also need to change this to node 1 and node 2. And we could potentially split these apart and do some nice default definitions. But to be honest, I think I'm happy with this solution. I feel like it won't get much better. So there we have it. I hope that you enjoyed this video. Hope you learned something. If you have any questions, please leave a comment. I'll try to get back to you as quick as possible. Hopefully there's more of these videos to come. Thank you for watching. Goodbye.